Alrighty, so we're going to pick up where we left off last time. We've been talking about average rate of change. Can anyone remind me what we're calculating, what it looks like when we find average rate of change? Similar to slope, right? Same idea as slope. So as we're finding average rate of change today, remember that we're using slope formula essentially. But when we're not looking at a linear function, we talk about this rate of change rather than slope, right? Absolute value functions don't have slope. Quadratic functions, cubic functions don't have slope. Okay, square root functions don't have slope. So we talk about that rate of change. So far, we have seen a few different ways that we can describe our intervals. The last example we did last time had this notation with our inequality, okay, to describe what values we're looking between. We have also seen just an in-words description from when x is -1 to when x is 0, or this interval notation. So from when x is 0 until x is 2. So a couple different ways that we can describe this. So we're going to pick up with example 5 for today. And we want to find the average rate of change for this function on the interval. We're going to start with 0 to 4, and then we'll talk about another one. Okay. So we did a very similar problem yesterday. Remember, when I've got the function and I'm looking at that interval, these are x values. And so I've got to plug in these x's to figure out what the y values are that match them. So that's what I'm going to start with. So I've got to start by finding f of 0 and f of 4. So for f of 0, that's 0 squared plus 3 times 0 plus 1. So that's 0, and we just get 1 here. So I know my first point would be 0, 1. And then for my second point, I have to find f of 4. So that'd be 4 squared plus 3 times 4 plus 1. 4 squared is 16 plus 12 plus 1. So 16 plus 12, that'd be 28 plus 1 is 29. So I also have the point 4 comma 29. I want to find the average rate of change between those 2 points. Okay. For our earlier examples, towards the beginning of our notes yesterday, the beginning of our average rate of change notes, a lot of times you just got the points, or we had a graph and we could just find the points. These are maybe a step or two more because I actually have to go find what that y value is, what that function value is. But once I've got my 2 points, I'm calculating slope, right? I'm finding slope between them. Okay, question? Okay. So if you're a labeler, x1, y1, x2, y2, and it will be y2 minus y1 over x2 minus x1. On top, 28. On bottom, 4. 28 divided by 4 gives us 7. So our average rate of change between 0 and 4 on the interval 0 to 4 for this function f of x is 7. So would we expect our graph to be increasing or decreasing over this interval? What did we say? Sorry. Increasing. How do you know it's increasing? The rate of change is positive. Yep. So between those 2 points, 0, 1 and 4, 29, I'm increasing. Does that mean my function is only increasing between those 2 points? Not necessarily. This is a parabola here, so we could, if we wanted, find the vertex and see if what side of the vertex this is on. Are they both on the same side? Then we would know for sure we're increasing that whole way. But I don't need that information for this problem. I just want to know, on average, are we going up or down or staying constant over this interval? For B, same idea, but this time I left one of them as A. So we're going to start by finding f of 0, which conveniently we already know, right? We already found f of 0. We know that it's 1. So we've got the point 0, 1 we're working with. And then we also need to find f of A. I've left this in more general terms this time. Okay? Some of your future courses, you're going to be working not with specific values all the time, but more in terms of a like different constant. Okay, so that's what we're going to do here. So I'm just going to replace x with a, and I get a squared plus 3a plus 1. So my other point, this is a little weird to write out, but it's a comma a squared plus 3a plus 1. And then I'm going to treat these just like x1, y1, x2, y2. And I'm going to find that average rate of change. So I have y2, a squared plus 3a plus 1 minus y1 over x2 minus x1. I've got some like terms I can combine here on the top. 1 minus 1, those are gone. And on top we have a squared plus 3a. On bottom, a minus 0 is just a. I want you to notice on top here, both of our terms have a, so we can factor out an a to be able to reduce. Does this seem at all familiar from last week? We did something where we combined like terms, we factored stuff out last week as well. If it doesn't just yet, give it a second. So we would get a plus 3 over 1 there, which would just be a plus 3. So our average rate of change over the interval from 0 to a, meaning we could put in any number we want for a, can just be described as this. So I want you to think about that for just a second. I'm saying my rate of change, if I go from 0 to any number, would be equivalent to 3 plus that number. Now for a, we went from 0 to 4, and we got 7. Does that make sense? That number plus 3 was our rate of change? Yeah. Okay. Now that's specific to this function, but the thing that this should look familiar from was earlier in our unit when we talked about this guy, the difference quotient. That's like the whole point of him, right? Is to be able to tell you for this particular function you're looking at, if you go from like 0 to a or -1 to whatever, usually we're counting from 0, because usually we're looking at positive values. But if I'm looking at a particular function over an interval like this, and I want to leave it general, so that way I don't have to calculate it individually a whole bunch of times, it gives me something like this, right? That's the same as the difference quotient, okay? And I want you to notice, if I use 0 for x, right? If I use 0 for x, this is exactly the same thing. This would just be f of h, or in our case up here, f of a, right? Minus f of 0, which is what we did here, over, for ours that was a minus 0. Since we're subtracting 0, we don't need to write that part. And so the idea of the difference quotient that we looked at earlier, right, last week sometime, we didn't get into the like meat and potatoes of that, and we're still just sort of barely scratching the surface on difference quotient, because that's something I want to introduce but you'll use later. The idea here is that it's giving me like a shortcut way so that I don't have to go through average rate of change every single time for any two values I want to look between 0 and anything else. I don't want to have to figure this out from scratch every single time. That's what that difference quotient is for. Questions for me? I am not asking you to have in-depth knowledge of difference quotient at this point. We are just introducing, talking about it, using it the way that we've used our average rate of change here. We're just identifying, hey, this is kind of similar to what we did here, okay? I'm going to go through a couple more examples together today. For example 6, we've got a function graph here for us. For A, describe an interval where the average rate of change is positive. So instead of me giving you the intervals this time, we're going to come up with the intervals. Okay, an interval where the average rate of change would be positive. Okay. There are a lot of different options. If you wanted to pick an easy interval, you could go from maybe an x value of -1 to an x value of 0. Right? If I found the slope between those 2 points, it's going to be positive, yeah? That works. I could expand this to go to 1. So from -1 to +1. That's going to be positive. I could expand it to 2. -1 to 2 would also have a positive rate of change. I could go from 0 to 2. That would also have a positive rate of change. I could go from -2 to 2. A little bit bigger interval. The whole function over that time isn't increasing, but the average rate of change is positive. So I'd have a positive like slope to that line that we're looking at between those 2 points. So from -2 to +2 is another one. I could go from -2 to 5 if I wanted to. You guys see what I'm looking for here? 2 points where if I drew a line between them, it'd have a positive slope. That's a positive rate of change. Now, I want you to try B. Give me an interval where that average rate of change would be negative. Average rate of change would be negative. Anybody think they have one? What'd you get? From 2 to 4. So from 2 to 4, yep, that's negative. Anybody have another one? -3.5 to -1.5. Sure, that'll work. Anybody have another one? We get one more? Oh, I did. Wait, hang on. 3.5 would be here. There we go. Well, -2.5 to -1.5 would be another one that would work. But yeah, you had a longer one. -3 to -2. That would work. Yep. Could I go from, let's say, -3.5 to 2? Could I do this one? Yeah, also negative. A lot of options here, a lot of possibilities. What about where the average rate of change is 0? Switch colors again since I've scribbled all over this. -3 to +5. What were you looking for? Why did you pick those values? They're both on the x-axis, right? They're both points on the x-axis. They form a horizontal line, right? It's one's not higher or lower than the other, but they have the same y value is really what we're looking for here. So -3 to 5 would work. 2 to 5 would also work. Or -3 to 2, that would work as well. Do I have to pick points that are on the x-axis? No. If I went from, most of my nice points are on the x-axis, so that's a good reason to pick them. But let's say if I went from here to here, whatever those values happen to be, as long as they have the same y. Could you do what? 1 and 3, yeah. They look horizontal to me. So if I've got positive, if I draw a line between those 2 points, there we go, positive slope. If I want negative, that means I draw a line between those 2 points and I get a negative slope. For no change, okay, average rate of change is 0, or the average rate of change, right? We'll just stick with 0 here. Horizontal line, right? Line with 0 slope. And I think we've got one more example for today. I can turn my page here. So for our last example, okay, number 7, we've got 3 different functions defined here, f of x, h of x, and g of x. And we've got 3 different representations. So kind of bringing together everything that we've seen so far. We've got a graph, we've got a function, we've got a table here. Order the functions from least to greatest according to the average rate of change over the interval from -4 to 5. From -4 to 5. So that means we need to start by finding the average rate of change over this interval for each of our functions. Okay, that's step 1. So for f of x, the nice thing here is we have a graph, so I don't have to calculate those. And I know the grid lines are pretty faint here, but I believe this would be -4, 25. And then when x is 5, so there's 2, 4, this would be 5 here. So that's the 0.5, 0. So we'll find our average rate of change between those 2 points. That would be 0 minus 25 over 5 minus -4. So -25 over 9. So between 2 and 3, closer to 3. We'll see how exact we need to be in just a second. For h of x, same thing, but this time we're going to have to actually plug in those x values to find our y's. So I've got to find h of -4, like we did for our first example today. Gotta plug that x value in. So this would be -4 squared minus 5 times -4 plus 42. That would be 16 plus 20 plus 42. So we would get 78 there, right? 62, 78. So I have the point for this guy, -4, 78. And then h of 5 would be 5 squared minus 5 times 5 plus 42. So 25 minus 25 plus 42. That one's a little bit easier. And then we find the slope between those 2 points, or the average rate of change between those 2 points. So that would be 42 minus 78, 5 minus -4. So we get -36 over 9, which simplifies to -4. So for f of x, -25 over 9. For h of x, our average rate of change over that interval is -4. And then I just have one more to find. There's h of x. For g of x, -4 to 5. This would be 8 minus 98 over 5 minus -4. So this would be -90 over 9, which would be -10. So for g of x, we get -10. Now we want to order these. Okay, so we found all those rates of change. Now we want to order them. We want to order those functions, okay, according to their average rate of change from least to greatest. So least to greatest. Okay. So smallest change to greatest change. I want to point out it says change, not the actual value itself. So if I am looking at, let's say, a change of +2 versus the change of -7, which one is the greater change? Yeah, I'm changing by more when I subtract 7 than when I add 2. So be careful with that. So which of these functions had the least change? The first one, f of x. This was, we said, somewhere between -2 and -3. I think if we type this in our calculator, it's like -2.8-ish. So f of x had the least change. What would be next? H of x, meaning that g of x had the greatest change. If I ask you to order these by the value, this is the smallest number of the values that we found, right? But I'm asking about that amount of change. So f of x, h of x, g of x would be our order there. Questions for me? Mm-hmm. What did I do? What? For the table, so we're looking at x values of -4 to 5. Does that make sense? Okay. Other questions for me on average rate of change? Okay. Let's, alrighty. I want you guys now to work on the practice problems on, would be the bottom of page 26 on to page 27.